Greetings. Welcome to today's lesson on slope-intercept form of a line. Now we had a part, this is be part 2. We're going to learn how to write our own equation based on basically just about anything that they might be inclined to give us. Either they'll give us just the information at hand, maybe they'll give us a graph, maybe, this is probably the most important that they will use, is they'll give us 2 points and just say, what's the equation of the line passing through these points? That's one of my favorites because that really forces us to go through a lot of interesting little, I don't know, give and take stuff, whatever you want to say. Okay, so let's go back to, let's make sure we understand slope-intercept form of a line. Y equals mx plus b. And again, m is our slope, that's our rise over run, it's how we're going to move, and b is our y-intercept. That's where we're going to begin on the y-axis. So graphing from slope-intercept form is actually relatively easy. If you give me the slope, you give me the equation, I can put that onto a graph, no problem. The real challenge comes when you want to go the other direction. So how do we come up with the equation based on information? So we'll start with the easiest setup. The easiest scenario is that they sometimes will say, you know, hey, what if I just give you that m is 3 and b is -1? What do you do? Well, that's just replacement. There is nothing to this. You simply say y equals 3x minus 1. Now, let me actually back that up just a heartbeat. I would actually put 3x plus -1, but you will never see them write that. They will never write plus a negative. This is just 3x minus 1. Remember how I could use queso and change this to addition, change this to its opposite? They would do that in reverse. They would undo my queso. They take the cheese off. Why would you ever want to take cheese off anything? Cheese is great. But this is how it has to come out. Okay, so this would be the equation based on the information that they gave us. If they gave me that this was a positive 1, I would put a plus sign. If they give me it's a negative sign, I'd put a negative sign. That's actually the easiest, okay? That's the most common, simplest form that they're going to give us, okay? The next possibility, this is where it gets a little more difficult, maybe even the most difficult, is simply when they give us a graph, okay? Now, if they're expecting us to do it from a graph, then they're going to have to do one thing for us. Actually, 2 things for us. The first is they're going to have to make it very, very, very obvious where it hits the y-axis. That has to be clear, okay? It doesn't necessarily have to be a point, but it has to be exceptionally clear. And I would say most of the time they're going to give it to you as a point. Okay, and then the next is they have to give us at least one more point somewhere on the graph that we can identify its actual coordinates of. And then we have the option of using the coordinates or just using the graph itself. So I'm going to do it once with the coordinates, and then I'm going to do it once with the graph. So if I were to put it, let's say right there, I'll make my life really easy. So there's my line. And those are my 2 points. Now, I know I need 2 pieces of information. I need to know the slope, and I need to know the y-intercept. Not necessarily in either order, but since it's in this order, let's do it in that order. So the slope, again, it's the rise over the run, and I go from one point to the other. So I'm going to put my pen on either point. It doesn't matter. Since I read from left to right, and I visualize from left to right, I can see this is a negative slope, so I know in my mind and in my heart this is going to be a negative number. The type of the slope and the number are the same, have that same connection. So I'm going to put my pen on the first dot and I'm going to count the rise. 1, 2, 3. But I went down, so that 3 is going to be negative. I go to where I ended. Now I'm going to run 1. Okay, so my slope is -3 divided by 1, or simply -3. Then I'm going to go back to the graph because I need to know the b value, the y-intercept. Where does it hit the y-axis? Well, again, that needs to be very obvious, graphically speaking. So I need to be able to see that. And I can. It's clearly hitting at 3. Positive 3. It's up here. Right? Here's 0, 0, so this is up at 3. So now I can write my equation. Y equals negative 3x plus 3. So it's definitely more difficult to go from the graph to the equation than it is to go from the equation to the graph. Okay? That's one of the big areas that I think is the challenge. Now, the last possibility would be, what if they gave us a couple of points and they just said, sometimes they love to say this. And actually, we'll get into a little more complicated stuff when we get into point slope form, which will be the next set of lessons. That'll be the next set of lessons. Is, what if they just give us 2 points? And they usually will say, write the equation of the line passing through the given points. So let's do that. So I'm going to keep this, I'm going to keep all that up there just so we have it as a constant reminder. And it'll say, write the equation of the line passing through the given points. And I'm going to make this easy on myself. I don't have to, but I'm going to. How about 1, 2, comma, 3, and 3, 4. Now it's interesting because when you see this, you might start making assumptions about like maybe what the slope is or where is it at the y-axis. Now we have a couple of ways we can handle this, okay? And I'm going to show you both, okay? Because we know how, one of them is graph it. I love graphing it, just if nothing else, just so I can find the slope. The numbers are small, so I can do that. That'll help me visualize. It'll let me know if I'm positive or negative and so on. It'll also make it, even if it's not perfect, it'll make it pretty clear where it's hitting the y-axis. So let's do that. So here we go, draw our little graph. There's my x and y. So 1, comma 2 is right there, and 3, comma 4 is right there. Okay, so not perfectly drawn, and that may be even the best but it makes it pretty clear to me that it's probably right there. That's my guess. It seems pretty obvious that, you know, if I drawn it a little bit neater, maybe I would have hit it right on the nose. But either way, it's pretty clear that that is almost certainly going to be my y-intercept. Okay? But I digress. Let's find the slope first. Okay, again, rise over run. So I'm going to put my pen on the first point, and I'm going to count my rise, 1, 2. I'm going to count my run, 1, 2. Well, 2 divided by 2 is a slope of 1. Oh, that makes my life very easy now, because I can use that to go back to finding my y-intercept. I have 2 ways that I can do this. Okay, one is visually. Let's do that. Okay, if I'm just a slope of 1, that means I could go, so from here I go down 1, back 1, right there on the line, down 1, back 1, right on the line, down 1, back 1, right on the line, and on the y-axis. That's certainly telling me the y-intercept is 1. But what if I couldn't see that? What if it wasn't clear to me? What if it was something horrible like a fraction? What if it wasn't a nice, neat 1? What if it was something awful? I still have an option. I still have a way to find the y-intercept. And that is the real challenge I'm going to show you right here. Okay? So, I already know the answer. But how would I find it if I couldn't do it visually? Well, we already know, so I'm just going to rewrite them. We already know that's them. Well, two things. All right. I find the slope using the slope formula. That's still the way I do it. Or I could have done it by counting the rise and the run, right? I could still use the slope formula. M equals y2 minus y1 over x2 minus x1, which means 4 minus 2 over 3 minus 1. And again, hey look, 2 over 2. Again, my slope is 1. Okay, so we knew that was what it was going to be, but we could do it using the formula. We didn't need the graph at all. Graph has advantages, but again, what if the numbers were big? What if they were uncooperative because they were decimals or fractions or just something I didn't want to deal with because they were too big? Just didn't want to. I want to use the formula. Formula works every time. But now what do I do? Well, I have M, and then I have 2 points. And here's the beauty. I can use either one. I'm going to use the smaller one because I can. This is an X, and this is a Y. Remember, what am I trying to find next? I've already found M. I need to find B. I have an equation right here that has that B in it. I can put the 2 in for Y. I can put the 1 in for M. I can put the 1, this 1, in for X. And now I'm going to figure out what the B value is by solving, just like we did many, many weeks ago, if you remember. 1 times 1 is 1. Subtracting 1 from both sides, and what do you know? B, in fact, does equal 1 exactly. So even if the numbers were yucky, what if they were big? What if they were 22 and 5, 77 and 30.6? God, make them horrible. I could still use the formula. It'll work. I'll get a decimal. I'll get some kind of crazy fraction. I can then use that crazy fraction in one of those 2 points to do this. Now remember, I said it doesn't matter which one. Just because I want to, because I can. What if I had used 3, 4 instead? Still as my X and my Y. I would put the 4 in for Y. The M is still 1. The slope is still 1. And the X is 3. 1 times 3 is 3. Subtract 3 from both sides, and look what happens. Same exact answer. Because what you're doing at that point is you're asking the line, where do you run into the y-axis? And every point on the line better tell you the same answer. Right? It's like asking 2 people, where are you guys meeting for lunch? If you don't give me the same answer, you're not meeting for lunch. Right? If I ask 100 people, where are you guys going to, where are you going to watch the movie? You better all tell me the same theater or you're not going to the same place. You ask all the different points, where do you hit the y-axis? They're all going to say it's right over there at the point 1. At y equals 1. Okay? So that is how we can write our own equation based on 2 points. We saw how we could do it if we just know the M and the B. And we can do it if we have a graph. Again, graphs have to be a lot more kind to us. Although you could take a graph just as one more little, so I'm going to do one more here. It could be could have a point here that I identify as -2, 1. And I could have another point down here at, well, let's go 2, -3. When I connect them, it's really not clear where I'm crossing the y-axis. It's very unclear, in fact. Okay, it's somewhere, I have a ballpark, so I know when I go looking for it, that my answer should be somewhere between 0 and -1. But Clearly, it's not a whole number. It's not hitting right on the -1. It's not hitting right on 0. It's hitting somewhere in between. So now I'm going to have to use what I just showed you. First, I'm going to find the slope. So we're going to go y2 minus y1 over x2 minus x1. And a little queso is still my friend. Okay, so this is going to be a -4, and this is going to be a +4. -4 divided by +4 is -1. Okay, so a -1 is my slope. And then I'm going to use one of my 2 points. Kind of really doesn't matter to me much because one has positive, one has a negative. If there's one that has like 2 positives, I always like that. If one's got a 0, I love those because they're really easy. But I tend to try to look for the numbers that I think are the easiest. Which ones are smaller, which ones are all positive or whatever. So I'm going to grab this one because it's the closest. So x and y. So again, my y is going to be 1. Here's my y. Equals my m, -1, times -2, plus my b value. Okay? So -1 times -2 is +2, oops, plus b, and when I subtract 2, you know what? I actually get -1. So what that tells me is my drawing stinks, but my answer is okay. Okay, so I tend to think, I trust my math skills enough that I realize my drawing skills are terrible. I mean, if you came to me and said, all right, which you're going to rely on, math skills or drawing skills, I know I can't draw. So I know this probably should have been a little bit lower, maybe. Hey, look, now that I'm drawing it a little neater, look at me crossing right at that -1. Okay? Should have picked one that came out as a fraction, but I didn't. It actually works out just as well. Okay, the process is the same. Okay, I find the slope using the formula. I use the slope and one of the 2 points, it doesn't matter which one, by plugging it into the slope-intercept form to then go ahead and find the intercept. Okay, it's not a quick process, certainly not an easy one, not one you're just doing like that. You're going to have to work at it. But once you get it, it's so much easier to be able to go from I can read this graph to I can read this equation. I know what this equation means. Oh, so let's write the whole final equation. Y equals -1x plus -1, and then we're going to neaten this up to be y equals -x. We wouldn't even bother with the -1 part. -1. And there's the equation. Okay? All right. I think we really have a good grasp now of slope-intercept form, of reading it, writing it, using it to create graphs, using graphs to create it. All right? So I will see you in class or in office hours.